Hello friends, very good morning. In this video, we are going to draw the projections of a square pyramid of side of base 40 millimeter and height 60 millimeter. And let's see what is the question we have got for today's video. The question reads like this: a square pyramid of side 40 and height 60 while resting on one of its base edges on HP. So whatever may be the question, it is resting on on the base on HP such that the one of the base edge on which it is resting appears as a rectangle of size so and so. Just on HP, its base appears as a rectangle. So friends, if you place a square pyramid on HP, the top view is going to be a square. That is very obvious, and we have worked out a lot of problems on such solids. And now, when it is being tilted on one of the edges to your right side, what happens? It rests on that edge, whereas the other two edges which are perpendicular to that, no, they get reduced depending on the orientation of the pyramid with the HP. So what do we do? First of all, we will write the top view of the pyramid and the front view of it when it is resting on its base on HP with one of the base edges normal to VP. So friends, here I am going to construct a square of the given side. Say this is the square and it has got a dimension 40 So I'll say SQ40. That is to say it has got a dimension of 40 millimeter. We will join all these corners to the center to indicate what are called the slant edges. And friends, we will name this as A, this is B, C, and D. And remember friends, this can be marked either in the clockwise direction or in the anti-clockwise direction. O is the vertex, friends. This is how the top view, it appears. So let me project all these lines and obtain the corresponding front view exactly in the center. You know the height of the solid and you can obtain O dash, the vertex, and join that to all the base corners, namely A dash, B dash here, and here O dash, C dash, D dash, and this is the base of the solid. And friends, here this is O1 dash. Now the axis O dash, O1 dash of the solid is normal to HP or perpendicular to HP. Now friends, in the question it is said it is tilted on one of the shorter edges such that it appears as a rectangle in the top view. What is the size of the rectangle? It is 30 by 40. Friend, this side CD and AB, which are perpendicular to VP, remain the same. They don't change. Whereas the lateral dimensions, BC and AD, they change in dimension in the top view. That appear to change when it makes an angle with the HP. So friends, we are given that it is making an angle or the size of the top view they have given. So we will construct another a rectangle adjacent to this, and we will mark this as it is. This is D, this is C, this is A and B. A, this is B, and it has got a dimension of 30 millimeter in the top view, and this is 40 millimeter. So the dimension of these vertical edges, namely AB and CD, remain the same. So friends, it is going to rest on this. So this is a fixed point. So we'll call it as C dash D dash in the front view. And friends, how to obtain this figure here? You know, you have this side AB. You can write a vertical line through this, a thin vertical line passing through that. And now friends, the base has got a dimension 40. Taking C dash as center, C dash D dash, and radius equal to 40. I just draw an arc. I join that and obtain what is called the base. So the base of the solid is here. This dimension is exactly equal to this. Mark the center of that. From there, mark a height of 60 millimeter. So this is how the figure appears. This is a O dash. Join that to O dash. From there to C dash D dash. Friends, this is how the pyramid looks when resting on a side CD on HP with the base ABCD appearing as a rectangle of side 30 by 40 as per the problem. Friends, these are the base edges. Let us obtain O, the vertex of the solid. I have a vertical line from there, a horizontal line from here. The point of intersection will give you O. And friends, you can see when you look from the top, you will be able to see what is OA, what is OB. They are visible to you. So I am going to join O to A by a visible line, O to B by a visible line, then O to D also by a visible line, and O to C again by visible line. And here you have got the axis. You can mark that is O1, join O to O1, showing the axis, and this edge is completely visible. Now friends, what is not visible in the top view is when you look from the top, the edge CD or C dash D dash on which it is resting is not visible in the top view because the body is an opaque body, and hence I have to show this by a dotted line indicating that the edge on which it is resting, that is C dash D dash, is not visible in the top view. Friends, if you observe this figure, you find that the object is resting on CD, that CD is now perpendicular to VP. But what is say in the problem? Draw its projections when the edge on HP is parallel to VP and nearer to it. It is resting on its CD. That CD is now perpendicular to VP, but that has to become parallel to VP. So I have to rotate this figure through 90 degree so that this edge is towards nearer to the vertical plane. So first let me construct that rectangle 40 by 30. This is 40 and this is going to be 30. And we can mark this. This is a dotted line. And friends, here we are going to have the vertex somewhere here. Join all this by full lines. Full line and this by full line. So I joined all these, and the last edge is AB. I can call this as AB. This is C. This is D. The center of this is O1. O1, you can say this is the axis of the solid, and we join all these. And now friends, you will have to obtain the final front view of the solid. So let us start from this edge AB. Draw a horizontal line through this edge AB. So to get A dash, write a vertical line from A to intersect this line at point A dash. Similarly, write a vertical line through B to intersect this line at B dash. So I will show like this. And then you have got friends C and D. C and D are here. A, B, C. This is C. This is D. I will say C dash and this is D dash. Friends, you have got finally to obtain the point O, the vertex. Draw a horizontal line through O dash, a vertical line through O, that this line is going to meet exactly in the center. So I will simply show a line here. Friends, this is our O dash. Now we have to join all these by straight line. So I have to join O dash to A dash, full line, O dash to B dash, full line, O dash to C dash is another line, O dash to D dash. Both OC and OD are visible. This is the last edge that is visible. And friends, this A to D is visible. And since it is not touching any other lines. These are full lines only. So you got A, B, C, D, and you got this point, say O1 dash here, that is O1 dash. What is not visible, friends, here is that edge AB. That edge AB of the base is away from the observer. That is not visible. Hence, I have to show this by a dotted line indicating that it is not visible. This is the axis O dash O1 dash. Friends, this figure is going to give you the front view of the solid and this is the top view of the solid. Before I conclude, I would like to remind you once again that figure number 1, the front view, and this front view in the second position, they are exactly identical. Similarly, this figure and this figure are exactly identical. So these two are exactly identical. And this condition I told you is applicable for all the solids and the laminae. So if you remember this concept, you can solve any of these problems very easily. Friends, this is how we come to the end of this session. And I hope that the presentation was interesting. Please go through the complete video without skipping any part of it in between. And share this video with all your friends if you like this video. And friends, if you have not subscribed to my channel till now, please do it at the earliest and have a wonderful day.